Hi, I'm Christoph from Berlin, Germany, and I work for KDAB. And in this series, I'm talking about how to speed up your day-to-day development life on embedded. Today, we are going to talk about bundling your executables for faster startup and development. To demonstrate what I want to show you today on a real-life example, I built this cute little Qt 6 animation on this iMix 6 quad-core board that we will see again later in the video. In embedded, you often have more than one executable on your board. If it might be a split between front-end and back-end, or even a microservices architecture with more than 30 executables, just copying your UI often is not enough for a complete deployment. That means if you want to test your latest changes, you need to restart all the executables in the right order. Doing this by hand, and every time you change something, this will steal you a lot of your work time. The first option to solve this problem is a deployment script, and I use deployment scripts in almost all of my projects to save time. What a simple deployment script needs to do is basically 4 things. The first, possibly you need to check and recompile your software to really make sure you will now deploy the latest version. Second, stop the old programs on the board. That might be necessary to do that in the right order. Copy over the new executables on the right places. And lastly, start the executables also in the right order. With this, you should be able to see all your changes on the board right away without a reboot. Here's the classical script that I use so often. So this is the script I'm talking about. First of all, I need to make sure I have a connection to my board. For this, I have this little SSH configuration line here on top, where I set the host of my application to whatever the name of that host is. I will be using SSH shortcuts for this. If you don't know how that works, you can look it up in the link below. Next, I have the build step. I told you that I need to rebuild. So what we do here in this script is to call make. And because I have many cores, I call make -j6 to have multi-core building. After that, I use a little trick. Sometimes there's still debug symbols in my executables. So to remove them, I use the program's EU strip to strip away the debug symbols. I do that for the front end and the back end here, just for example. Next, we need to kill the applications on the actual device. And for this, I'm using SSH to kill all of the front-end and the back-end applications that are currently there. Here, you really have to remember that your programs shouldn't be an auto start. Otherwise, they will restart right away in the old version and you will not see your new version. Next time, sometimes it is necessary to unprotect your root file system to be able to actually write to your board. And with this little command, I'm actually able to do this, and this is kind of a preparation step for now copying over the application. Here I then just copy over the application. After that I use the start. Remember, I first killed the front end, then the back end. Now I need to start the back end first and then start the front end, and after that I should be good. And with this script now I can just start the built-in updates script, which will first build and then deploy and then restart my application on the embedded hardware. You can achieve the same in Qt Creator. This is really the same, but you will not need to change to your console in between. Instead, you can simply press Ctrl+R or the green arrow on the bottom left, and all those steps will be done by Qt Creator. To set this up, I will explain it how that works. First, you need your cross-compile environment set up for your Qt Creator. This is something that I won't get into detail in this video. Our friend Burkhard Stubert wrote a detailed blog about this. I link it in the description. So to achieve this, we first need to go to our preferences, and here we go to the Kits tab. At kits, you will see all the kits that are currently configured for your Qt Creator. That might be desktop, you will see all of these, but the rest will be other boards. And we want to add a new kit for a new board. So I click on Add, and I will name this new one IMX6 just as my board. And you will see a bit more down that there's a run device type. Standard will be desktop, but I will not use desktop, but remote Linux device here. I click this, and then for the run device, some boards will be shown that might or might not be used for this kit. I need to click Manage because I have a new board. So I need to add a new board for my device configuration, my kit here. I click on Manage, and then I say I add a new board. Add here, and there's a little window which asks me, do you want to add a remote Linux device or a QNX device? I want a remote Linux device in this case. Here I can start a wizard which will guide me through the process of connecting to my board. The name is again IMX6 Saber. This is the name of the board. And the IP address I need to know. It is a different one. It's like this one, 162. You need to provide a port for your SSH. You usually have port 22. That's the standard for SSH. And the username to log onto this device is root. If I click Next, it will now check that all my SSH settings are good. Because I don't have a password here, that's not necessary for my board in this case. I can click on Next. And now it will run an automated test to see if some programs that Qt Creator might need are actually on this board. If I click Finish, you will see this test running through. You see there's lots of tests. And here you can see my device test actually finished successfully. That means I have successfully added this board. And with this, I also have successfully added this device. And when I go back to kits, I can now choose this device, IMX6 Saber, as the new run device. That is the first part that we need to do a connection between Qt Creator and my board. So now we are here in the actual project that I want to put a deploy configuration for on Qt Creator. I go to the projects pane on the left side of my screen, and then I can see all the kits that I could possibly run this application with or compile the application with. And now we will see that there's actually a new kit that I can pick here, which is the IMX6 Saber kit, which we just created before. When I click this, there's two sub configurations there. There's the build part and the run part. The build part is only for cross-compiling. We are not interested in this here. I will click now on the run part. Running on your normal desktop usually means just running the executable on your machine. But on a remote host, it means more. It means deployment and then a remote execution of the program. So we see Qt Creator is trying to help us already here with the deployment. We will see multiple sections on the Qt Creator run settings, which are called deployment, run, and environment. When we look at the deployment first, we can see many methods that we could pick to deploy our applications. Here, we just picked the standard one, deploy to remote Linux host. That means because our kit is already configured to our new machine, it will automatically deploy our newly compiled executable to the board. You already see that also Qt Creator tries to help us with killing the current application instance. And after that, it will upload the file via SFTP. Here is a little bit that I want to do extra. As you know, we might have a backend on this board as well. And for this, I need to kill the backend on the board as well. So what I can click here in this add deploy step configuration is to have a remote command being executed on the machine. And this would be, for example, kill all backend. You see it's already suggested here. And you cannot only add this command, but you can also move it up and down in the deployment scripts. So here we could move it, for example, up and kill it maybe right after we killed the front end, which is the current application instance. In this way, you can reorder all the individual sections, it's like script commands, that you will execute in your Qt configuration. For the run configuration, we actually want to start the backend first, right? So what we cannot do here is to run two executables in the run configuration itself. And for this, I use a little trick and use the starting of the backend still as a custom remote command. Here I will again add a custom remote command where I just run the backend. So I just say user bin backend here, and this will then restart the backend for before my application is actually run. Next, we can look at the run part of our deployment here in Qt Creator. Currently, the run configuration is set as a custom executable, but this is not what we want here. Maybe it's already set for you, but what we want is the executable name on the device. So for me, Qt Creator already created this run configuration called frontend on iMix Saber, which is the one that we really need. We can look further down here and we can see many options that we can put to our run configuration. One of these options would be command line arguments. Another one would be working directory. Working directory is probably fine for me, but the one that I want to change is the command line arguments, because I'm using Linux frame buffer here on my board. I need to say minus platform is Linux FB. And with this, I will have the right command line arguments on my remote board to start the application. This was a long configuration, right? Now we are finally able to harvest what we have planted and see that we are actually able to run the executables quickly on our Qt Creator. When I go to edit, I will now see that my run configuration in the lower left, where the little computer screen is, will not only be showing my Qt 6 kit, but also the iMix 6 Saber kit, which we now have configured in the steps before. I can choose between all the run modes that I know also from desktop, for example, debug, profile, and release with debug information. And I see also the run configurations where I also see the run configurations that we have just configured in the deployment steps in Qt Creator. With this, I can now select iMix 6 Saber, debug, and frontend, press the button again, and when I click my little green arrow here, you will see that my application will be now be deployed and run on my embedded board here next to me. Another option to deploy is often overlooked: automatic deployment. In my career, I often had the situation where a customer had many test machines sitting in testing rack. To always have them updated, a nightly build of the software was compiled and deployed, such that every morning the testers could re-evaluate the quality of the software on a fresh version. So having nightlies helps you on more levels than you might initially realize. First, obviously they're automatic, and so you don't need to work to get them on the board. Second, they already bundle all your apps because the update contains a combination of all software, so the versions of all components fit together nicely. Third, if you preserve nightlies, you will get an archive of ready-to-deploy software at your disposal. This is the coolest aspect in my opinion and saved me many times. Imagine a customer complaining about a bug. They are running on a previous version, obviously. With a nightly archive, you can just deploy the exact version to confirm the issue. Also imagine searching for the point in time where you introduced a bug. With nightlies, you can easily test if it already was there a week or a month ago and quickly pinpoint the offending code commit. So what I can show you for the nightlies is for my brewing customer. I have this machine here where we also maintain nightlies. So on my laptop you can see all the different versions that we have, and you can see they are here for basically all the days of the year that we're here. So if I want to update the device now to a version that is older than the one that's currently on it, I can just download, and my download will start. And once I've downloaded it, I can go on a web page that is actually provided by the device. So I just put the IP and I have a full interface to upload my firmware to the device. Click on Resend, I upload my firmware, and now this will take some time. The firmware will update and update the device, which will then restart and be on the new version. And as you can see, the device restarted again. The UI looks slightly different, and I now have a different version on this thing without recompiling on my desktop, but just using the nightlies that I already had laying around. So that's nice to have. In this video, we saw how we can use scripting, Qt Creator, deploy and run configurations to update our embedded hardware in one go. I also quickly showed you how to profit from running nightlies to speed up your development and also to have an archive. With all this, I hope you can improve your daily developer experience and save that little second of waiting here or there. So thank you for watching this tutorial. If you have questions or comments, just ask in the comments. And see you in the next video. Auf Wiedersehen and goodbye.